Hello everyone, this is Suja. Today I wanted to welcome you on my walk. Today I want to discuss man, myths, and methods, and kind of want to poke around the idea that science is basically a machine that turns phenomena into statistics. We'll get around to it, we may not, we'll see. But the idea is that mankind developed from using myths, stories, where he anthropomorphized the universe, to using methods to basically derive statistical rules about the behaviors of any given object in the universe. So let's start where man started, somewhere in a cave somewhere, okay? So mankind, he's coming out of a cave, he's primitive as hell, and he's looking outside and he sees stars and mountains and rivers and all these things, and he's like, the skies, they're full of these brightly amazing objects. Where these celestial bodies are gods. Oh, the river, it flows. How does it flow? The river spirits make it flow. Or, the moon, it's turning red. Oh my god, that's a bad omen, right? So man has these myths about the sky, the rivers, the mountains, and everything. So man has decided from the very first point of acquiring language and coming out of his cave to use language as a way to imbue meaning to the universe, and thereby meaning to himself, because man is part of the universe. And so in his mind, as he's making these narratives, he relates to the universe in specific ways. So, with the rise of myths came amazing things like religion and culture and society and all that cool stuff, which we still have nowadays, which is great. We haven't all died yet, so happy that human civilization is going on, and I hope it goes on forever. So as mankind developed all these things, he decided at one point, or rather he came upon the idea of reason, scientific enlightenment, the idea of materialism, where he saw that the universe was made out of matter, which really is energy, and he decided to explore this area, come up with different things like chemistry and physics and all these things. But all these things come from the idea that the universe's behavior, which can be modeled via the sciences, via math specifically, is constant. And to a degree, maybe that is true. Maybe the rules of physics change every quintillion years. So we're in such a big cycle that to us, who live roughly 100 years, if we do the best we can, we will never know, or we will never see the actual changes of the universe. That we have to, because of our short life cycle, say to ourselves that the behaviors of the universe, which we model our mathematics on, and so on and so forth, are A, constant, and B, are going to stay constant. But if you look at human life from the perspective of its very puniness in terms of time, let's switch from human life to flies. A fly stuck in an airplane will assume for generations that the air pressure is going to be constant for the rest of eternity, because it doesn't understand it's in an airplane, right? In the same way, human beings, which live very short lives in comparison to the universe, may never really understand what the hell it actually is outside that we see with our senses, and we have to assume certain behaviors of the universe are constant, which it may not be. So the fundamental assumption that we make in science, in all things that we test, is behavior is going to stay constant. But if you look at the universe from the point of view that it may not be that way, it's just we're too short-lived to figure out how the changes occur in the universe itself, then you're back to the whole mythos area. But we're going to say that the universe is constant in certain regards, and so the universe, which is constant in these regards, have certain behavior patterns which we can model using mathematics, and then using those mathematics we can develop physics and chemistry and all these things. And so now we have specific laws around these specific things. But understand, the laws that we have are not laws in the sense that they are absolute. The laws that we have probably can be broken, or maybe there may be loopholes in physics, right? So I'll give you an example. So star travel, faster than light drives, right? There may be a way to build a faster than light drive, hypothetically, theoretically, in theoretical physics, where you bend the space forward and you push it back out, and there's a whole thing about that. So, you know, there's probably loopholes in the so-called laws, but these are not laws. I want everybody to understand that I think of the universe as a specific set of behaviors of different parameters. Again, it's a hugely complex way of describing the giant complexity that is the universe. But okay, man developed methods to test and derive laws from these observed habitual behaviors of the universe. And as he did this, you know, he came to the conclusion that the universe is like a clock. It always goes tick, 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 tick. And if you had enough information, you can predict everything. Until, of course, you had quantum theory develop, where everything became probability, and the universe was no longer clock-like. So, as man discovers that basically everything in your life is a collapse probability vector, you have the underlying assumption that the universe is no longer solid, but the universe is a vector of probability, which leads to you to this interesting idea that what we really do in the universe using mathematics and science is we take phenomena that we observe and we turn them into statistics, which then we can, you know, draw inferences from and argue. But the process of turning phenomena into statistics can be corrupted in the sense that, okay, if you ask the wrong question, you get the wrong results, right? You get the wrong answer. You can get the answer, sure, but you get the wrong answer. So it's important to ask the right questions. It's important to understand the right things. The question is more important than the answer because of the fact that you can ask the wrong question. So the correct question is, what is the correct question? You know, it's not what is the meaning of life, but what is actually the question regarding life, meaning, and all of it, which is a whole other probably topic that I'll probably talk about later when I feel like it. But right now, I want to give you the example of hydroxychloroquine as a sort of base example to sort of jump onto. So you'll see all these studies and all these scientifically written articles that, oh my God, hydroxychloroquine doesn't work and it's bad for you and all that cool stuff. But the underlying theory here is, yeah, of course it doesn't, because your methods have been so that, you know, you are not taking into consideration zinc, which is hydroxychloroquine is a known zinc ionophore, right? So as these biased scientists, let's just call them biased scientists, make these studies, they can make it in such a way that it reaffirms their own beliefs. In one sense, what they're doing is they're statistifying the myths that they believe using the scientific method. And so that is what I wanted to sort of get into out of my head, is even in an age of reason and methods, it can still be corrupted. So it is still important for people on the individual level to understand how the hell the study is actually, you know, constructed and how it actually works, and the people behind it and what their biases are. There's always bias in any given area of life, you know, from finance to food to everything. There's biases involved, and people with personalities and paychecks are involved who have biases towards one way or the other. So in this sense, living in the era of relying too much on the science, right, isn't useful to you, because science is basically now a method by which those who have those lovely degrees can make you believe whatever they want, given that you don't question their methods and you don't understand what the studies are, or how the studies are conducted, and therefore you may not see the fact that, you know, the studies are bunk. So that is why no one should be truly too reliant on science as an action point. So there's a member, I'm a part of this group on Twitter, there's a member in there who's like, oh, you know, I have to be very scientific about all these things, and how do you know? Well, given that science is a method by which phenomena gets statistified, right? You don't necessarily need to have statistics to rely upon to grant you the ability to make decisions on your part to take actions towards this COVID-19 disease that deal with, you know, vitamin D and all the other things. So that's kind of what I wanted to say, but I really wanted to say it shorter, but okay, fine. I ranted on my phone. I don't think many people are going to see this, but even if they do, it's okay. It's out there. It was a very complex way to arrive at that point, but the grand idea is, as science is a method by which you take phenomena and make them into statistics and use those statistics as a way to relate to the universe, you need to understand that even without the statistics, the phenomena themselves are true. Okay, you can rely on anecdotes because just because it didn't go through the rigorous process doesn't mean it doesn't exist. So being over reliant on certain studies and not understanding how those studies are constructed, or using studies as your biases to dismiss idea because of your political ties, would be a wrong approach, subjective approach, a mythos-based approach, not a method-based approach. So I want everybody to understand that. I want everybody to sort of get that main idea from this long talk. And I kind of want to shut up now because I've talked a lot. All right, so have a wonderful day. Thank you for joining me on my walk and my mind and my talk and all that. And I'll see you guys in the next walk. Bye.